Don't build connectors for your AI application without doing these three things first. 1. Seamless and secure access to third-party data from sources like Google Drive, Notion, Salesforce. 2. Robust permissions on that data. Once you've ingested that data for your AI application, make sure it's only reaching the right users. 3. Data refresh policies. Your users' data is always changing in their Google Drive, always changing in their Notion, and so you need to make sure your AI application's database is also up to date with those changes as well. Ready to find out how to build an AI application with these three requirements? Let's find out how. Let's do some level setting and talk about what we'll be building today. So what we'll be building is our yourapp.ai application. Users will authenticate to yourapp.ai and then also be able to authenticate into their third-party data sources like Google Drive. From there, we can start using the Google Drive API to pull file data as well as file permissions for each file in their Google Drive and index the data to our vector DB, Pinecone in our case, for RAG retrieval, and index our permissions graph to make sure that all of our file permissions are stored there. So when a user chats with our application, first we retrieve any relevant context to their query, and then we check the file IDs and check with our permissions graph if they have access. From there, we return the allowed data back to the user. Let's jump to our production-ready requirements real quick and start with the first one, the seamless and secure access to third-party data. Third-party authentication isn't the flashiest feature, but without it, there's no way for you to get your user's external context to your application to ingest. So on the left, what we have is a couple of data sources, Google Drive, Box, HubSpot, and so on, and we let users hit the Connect portal and log into Box straight from our application natively. Here's how we actually built that Connect portal, where we let users connect to their Box or Google Drive, initiate a pop-up, and give you a login to log into that third-party integration from directly within your application. This is the yourapp.ai source code. And what we have is in a React component, we have a component where when a button is clicked, it calls the paragon.connect method. We pass in the integration type, which in this case was Box in my demo before, but with whatever integration, you can put in a string Google Drive, Slack, HubSpot, Salesforce, whatever you'd like. And then it brings up the Connect portal directly in your application. Our SDK provides a couple other methods. So we can see that we can authenticate to Paragon, you can close that Connect portal programmatically, as well as send events, and many others that we support. And that's all it takes to actually put in third-party authentication natively embedded in your application. With authentication out of the way, let's start getting to the fun stuff. I'm going to start pulling my Google Drive data and sync it to my AI application. In just seconds, we've synced and ingested all my Google Drive files from my account. Let's see how we're actually doing this in the codebase. Before we jump into the codebase, I want to show how Managed Sync works. Managed Sync is an API product that we use heavily in our implementation. So Managed Sync basically manages data pipelines to our users' Google Drive files, as well as any other integrations. It makes it really easy to actually perform data ingestion and get our users' data to our application. So here's how it works out. Part of Managed Sync is a set of two APIs, the first one being the Sync API. So we're calling a post request to the Sync API with Google Drive to spin up a data pipeline all on Paragon's infrastructure. It handles all the infrastructure around building the pipeline and actually uses the right Google Drive specific APIs. So we don't have to look up the APIs that we need to pull data, say from a Google Sheets versus a Google presentation versus a Google Doc. Once the sync is done, Paragon will send us a webhook telling us that the sync is complete. And from there, we can call get contents to the Sync API to actually get the file data as well as some metadata such as the URL, when it was last updated, and other fields to use in our application. Lastly, the Sync API sends us periodic webhooks to let us know when files are updated, permissions are updated, so that way yourapp.ai is always up to date with the latest information when data inevitably changes in our user's Google Drive. Okay, now let's get into the codebase. Implementing data ingestion is really easy with the Sync API that I just showed before. So first, we are initiating that post request to the Sync API, and we're passing in the integration that we want, in this example, Google Drive. And that's literally all it takes to start building a data pipeline using Paragon's Managed Sync. Flipping to where we're actually getting the Google Drive file data, again, we are calling the Sync API, but this time we're including the exact record and mentioning that we want the contents of that record. And what we get back is actually an array buffer. So it's passing us that raw data. And from there, we're actually using Pinecone to index that data. So we see on this line, I created a Pinecone service that upserts the raw text to a vectorized embedding. And here's where we're specifying the chunk size, some overlap, and pushing that raw text directly to the Pinecone API. So the reason this works is actually because Pinecone has an interface called upsert records. And if we go into here, we can actually see that if you have Pinecone's inference enabled, you can actually pass in a raw text instead of a vector embedding. It's a really powerful way to utilize what Pinecone's already built with all of their research into optimizing RAG performance and let them take care of all of the vector embedding as well as the retrieval. And you just worry about passing in the right text, which in our case is passing in our user's external Google Drive context and retrieving that with correct permissions. Let's jump back into our yourapp.ai demo and see that retrieval in action. I'm going to ask about some of our AE's lead performance. And we can see I can get Chad and Alex's lead performance, their conversion rates, and it's sourced from our Google Drive file where we can actually even see the specific chunk that it's referencing. This is a great MVP right here. We're ingesting all of our users' Google Drive files and able to search it with RAG. But what takes this MVP to production is being able to enforce permissions on it, as I referenced before when I was talking about the code base. So imagine that I'm not a part of the sales team. I shouldn't be able to query for sales performance data just because someone in my organization or an admin has enabled Google Drive ingestion for my enterprise. That's where the permissions API, the second part of Managed Sync, comes in. It makes it really easy to actually check permissions based off a permissions graph and make sure that your users are accessing the right data according to the authenticated user. Let's actually jump back into the code base and now enable permissions API, and then we'll actually hop back here and see what that looks like in action. In our code base, I'm going to now enable the permissions API and show you how it works. So the permissions API takes a couple of arguments. It takes the object, which is just the Google Drive file ID. You pass in what permissions you're looking for. So here we just want to restrict our file to the can read permission. And then we pass in the user email. From there, we're going to use the second part of Managed Sync, the permissions API, and call the batch check endpoint. From there, we pass in a list of all the different file IDs, the can read permission, and then the user email. And then it'll return a list of Booleans, true or false, on whether we have permissions from there. That way in our AI application, we can then only surface data where the user has access to that true field and pass in only context, those chunks where the user has permissions to. Let's actually enable it right now and run back to our application to see what the effect is. So now we're enforcing permissions. Give it a save, and let's jump back. I'm back in our application. I'm now going to copy the same question that I asked last time. I've given it a refresh, but I've enabled permissions as we saw before. And again, I'm not part of the sales team, so I shouldn't have access to these leads data. Asking again, it still used that RAG external data tool, but now it doesn't have any specific information because now we've locked that file with correct permissions. To quickly recap what we've done to take an MVP to production AI application, we've implemented third-party authentication and allowing users to OAuth into their Google Drive. We've now implemented robust permissions so that way, even if an admin enables Google Drive ingestion for your entire organization, our AI application will still return data according to the correct permissions of the native Google Drive files. And our last piece, which we're going to show right now, is how to make sure that our data is always fresh and up to date with updates to the file contents as well as the permissions. So here I have one of the files that has been synced by the Sync API. And it's a CSV with some data. And I'm just going to add a new line. I made some edits. Now let's jump back to our AI application and see how Managed Sync sends us webhooks that tells us that new data is available and that we can update our vector database. In our application, yourapp.ai, in our dashboard, we can now look at our sync events to look at all of our sync events that have happened so far. So you remember we initiated the sync for Google Drive. Then we did some data pulls to actually pull the object synced. And lastly, we just updated that CSV file, and we can see that just a minute ago, we get a record updated webhook, which passes us our file ID and then triggers our Pinecone service that we showed in the code before to re-index that Google Drive file data to our vector database. This ensures that our RAG application always has the most fresh, up-to-date data and therefore completing our production requirements. To recap today's tutorial, we built an AI application with RAG capabilities that have production-ready requirements in place. We have seamless and secure access to third-party data so your users can auth integrations like a Google Drive integration or a Salesforce integration. We then use the native integration provider's permissions in our AI application, so that way we can respect the original Google Drive permissions or the original CRM permissions as our user uses our AI application. And lastly, we showed how we are able to always stay on top of the latest updates in our users' data sources and notify our AI application so that way we can re-index our vector database and make sure that our AI application not only has our users' external data, but that data is up to date. Thanks for watching today's tutorial. We have a lot more great content coming up in this tutorial series, namely agent tool calls, as well as a deeper dive into permissions for AI applications. Thanks for watching and see you next time.